When you're asked to factor a trinomial whose leading coefficient is not a 1, you have two options. You can use trial and error, or you can rewrite the middle term. In this case, since the leading coefficient and the constant are prime numbers, trial and error is not all that bad of a way to approach this. The only two possible factors when you FOIL to give you 5w squared would be 5w and w. The only two factors that will give you a -2 are +2 and -1. So we have to test each of those combinations. So +2, -1, -2, +1, and then switch the terms +1, -2, -1, +2. So at most we need to test 4 possibilities. When we look to eliminate any of these pairings, there are none that have common factors, so I can't eliminate anything. And so when we look at this solution and we test it, we take our outer minus 5w, our inner plus 2w, gives us a -3w, not what we're looking for, so I can eliminate that one. Plus 5w minus 2w does not equal -9w, so I can eliminate this. -10w plus 1w does give me what I'm looking for, so my set of factors is 5w plus 1 and w minus 2. Okay. There's another way that you can approach this if you wanted to by rewriting the middle term, which is an efficient way. If you were rewriting the middle term, the approach for this involves taking your leading coefficient and your constant, multiplying those. 5 times -2 is -10. And then identify, are there two factors of -10 whose sum is this middle term's coefficient, -9? So -10 and a +1 work. So if I rewrite my middle term as the sum of those, drop my first and last terms down and factor by grouping, I can remove a common factor of 5w from the first pair of terms, leaving a w minus 2. In the second pair of terms, there is no common factor, so I account for that by putting a +1. I'm only taking out a +1, so I'm writing the remaining terms w minus 2. I have this common binomial factor of w minus 2, and the remaining factors 5w and +1 become the terms of my other binomial. So you can see these are the same thing. You can approach it either way.